Man, this video is going to be on quadratics. More specifically in quadratics, we're going to talk about domain and range and also intercepts. We're going to talk about intercepts from a graph and also by hand. So if you take a look at this graph here, we have a very distinct sort of U-shaped graph. If I go forward to these other examples I have, as you can see, it is a U-shaped graph as well. This is what's going to happen when we graph quadratics. Now this is called a parabola. That's how you spell parabola. That is just what this U-shaped graph is called. It's called a parabola. And we're always going to have a parabola when we're graphing quadratics. Anyways, the first topic is going to be domain and range. So if you remember back to the unit we did on functions, we discussed domain and range. So if we look at this graph, if you remember, domain, those are the x values, and the range, those are all of the y values. Excuse my handwriting. So we're going to first start with the domain. So you remember the domain, first of all, those are the x values, and the x-axis continues on forever and ever. So you got to use your imagination just a little bit and think about how this graph would continue on forever and ever. As you know, it doesn't just stop at these points. That's not how it works, is it has arrows on it, which means it goes down forever and ever. So this graph, if you think about it, it would continue down forever, but it's also going to gradually get wider and wider and wider. So if you remember, we had this funky looking notation where we had the curly brackets, and for this example, we would have x is greater than negative infinity, but less than positive infinity. So the left side of this graph, which I'm going to go over in green, right, that would gradually keep getting wider and wider to the left, all the way to the left until it got to negative infinity. Also, where I'm marking in yellow, the right side of this parabola, that will continue to get wider and wider and wider to the right, all the way to positive infinity. Now we can't ever equal negative infinity or positive infinity, so that's why I did not put the line underneath of the inequality symbol. So if you prefer that notation, you can use that. Another way that you could write this is so that notation, all it's saying is basically is x is part of the set of all real numbers. So either one of these will work. Both of them are saying, it's all real numbers. Every single x value is a part of this parabola. So that is two options for you. Now the range is going to be a little bit different here. So the range, let me erase my scribble for the domain. Now the range, if you remember, is the y-axis. So here's my y-axis. So the y-axis, just like the x-axis, is going to go up and down forever and ever and ever. So we got to think about this graph, and now we're not really thinking side to side, we're thinking up and down because that's what the y-axis is, it's the vertical axis. So as you can see, these two lines are just going to continue down, all the way down until it reaches negative infinity. So y is greater than negative infinity. However, this graph, it doesn't continue up forever and ever and ever because there's a point, there's a vertex here, which I'm highlighting in red. This graph doesn't go above that point. So y has to be less than or equal to, you got to figure out where this point is on the y-axis, and that point is at 4. So that is how we would write the range for this graph. Y is greater than negative infinity, but less than or equal to 4. The reason why it's or equal to 4 is because that point is on that line y equals 4. A much simpler way to write this, if you would like, instead of doing this notation, you could just write it similar to what we did with the domain. However, we're just going to include this kind of the second part of it. So all real numbers y such that y is less than or equal to 4. So that's telling us that anything less than or equal to 4 is a part of this graph, which is true. Alright, so we're going to go through this one a little bit more quickly. So the domain, remember this graph's going to go up forever, but it's also going to gradually get wider and wider. So x is going to be greater than negative infinity, but less than infinity. Another way to write that. And that's just an R with 2 lines down it. That just means all real numbers. And the range, we know that the range, it goes up forever and ever, but it never goes below this point. Hopefully you recognize that obviously in the previous problem the parabola was opening down. In this problem the parabola is opening up. So the range, we could write it how we did originally. Y is going to be greater than or equal to negative 4. Be careful there, it's different than the previous problem because now the graph is opening up, so my vertex is the lowest point on the graph. So y is greater than or equal to negative 4, and it goes all the way up to positive infinity. So that is one way you could write it. The other way you could write it is just simply y is greater than or equal to negative 4. That tells us that anything greater than or equal to negative 4 on the y-axis will be included in this graph. Alright, we are going to switch topics here. Well, first I'll just run through the domain and the range quickly. I'm going to write it in the simplified way. So the domain, again, is all real numbers because it's going to keep getting gradually wider and wider. The range, it never goes lower than that point, which is at negative 25 on the y-axis. So we know that y has to be greater than or equal to negative 25. So that would be the domain, or excuse me, the range on this parabola. The other topic in this video is intercepts. So, intercepts, the x-intercepts on this graph is simply where the parabola crosses the x-axis. We have 2 points there. So if we were talking about the x-intercepts, when you're given a graph, the intercepts are pretty easy to see because it's just where it crosses the x-axis. Now intercepts should be written as ordered pairs. So our 2 intercepts for this parabola would be negative 15, 0, and also negative 5, 0. If we were to go back to the previous graph, if we wanted to do the x-intercepts, they are, what I'm highlighting in red right here, 4 and 8. So written as ordered pairs, it would be 4, 0 and 8, 0. So this problem, we're going to solve the intercepts, but instead of giving you a graph, I'm just going to give you the quadratic. We're going to solve these algebraically. So if we take a look, remember that we talked about how f of x is kind of interchangeable with y. So we obviously need to solve for the x-intercept, or intercepts, plural, it's a parabola, so it's going to have two. But we could also solve for the y-intercept, so we're going to talk about that as well. Alright, so let's take a look. So if we're solving for the x-intercept, remember the x-intercept is where the lines are touching the x-axis. Now, if you look at the previous example, the y value is always 0. Whenever we're talking about x-intercepts, the y value is always 0. So, if we're trying to solve for the x-intercepts, what we're going to do is we are going to plug in 0 for y, because we know that that has to happen if we're talking about x-intercepts. So now I have a little equation, and I'm just going to go ahead and solve that for x. So negative x squared, if I want to get rid of that negative, I can just divide both sides by negative 1, so I get 4 equals x squared. Now to cancel out that x squared, I take the square root. So we get 2 equals x. Also, you have to remember, the square root of 4 is 2, but also negative 2. Negative 2 times negative 2 is also 4, just like 2 times 2 is 4. So my x-intercepts here would be 2, 0, and negative 2, 0. If we look at the y-intercept, same thing here. Anytime we have a y-intercept, the x-intercept is going to be 0. Excuse me, the x value is going to be 0. So, all we have to do here is we're going to plug in 0 for the x value. Negative 0 squared, that's just 0. So we're going to get f of x equals 4. So the y-intercept would be 0, 4. Now we could go ahead and we could take our y-intercept and our x-intercepts and we could go ahead and graph this quadratic by hand, but we will get to that in a later video.